of the drum above the surface, and you can calibrate both sides so the pressure is the same on each side. Hand drive through. Next operation is called center drill. So chuck would rotate. This would end up rotating if I the part's spinning, and these things don't rotate because the part's spinning. So I come in and what's called center drill, which is the starting drill to make sure that this drill doesn't walk and starts right in the center of the part. The turret part feature of it indexes the tools around, so I don't have to change them each time.
Right.
So I can drill it now to preset.
So you can get really precise.
Right.
Absolutely
and then
precise.
This is called tack. This would produce internal threads on the part, so I can come in and thread it. Okay, so that's kind of how that guy was set up. This one here is an engine lathe. This is the one we turn all the drums and cylinders on. They look like this after they've been welded. You start off looking like weld casing or a heavy wall pipe, and it's all welded up. They're driven on centers in each end. This is called a dog. Clamps to the shaft here, and then there's a pin that goes through the driver plate, which is this face plate here. So as the chuck or as the head rotates, it drives the part around and around. We use a carbide insert tooling. Basically, this guy turns on like this. So it's spinning when we bring in a cutter like this. Cuts the diameter back to where it's round again. So what we do is we machine this surface. We take a roughing pass, like that was a roughing pass, which we're basically trying to get it down, get most of the OD true, and get most of the rust off of it. Then we'll slow the feed down on it and come back and take a finish pass on it, so you get a real true finish and smooth. We'll face the ends on it. The ends of it are here, so we take a cut across the end so the part's the right length, and then we'll machine the journals. The journals are the part out here, and we have to turn those within a 1/2 thousandths tolerance so they'll fit in the bearings that carry it. So everything on that part ends up being machined so everything runs nice and true when it's in the press. So these are milling machines. These are vertical milling machines.
Kind of like a drill press, or
they're a glorified drill press is what they are. They have calibration on the dials here. Each of these marks on these dials, both X and Y direction, are calibrated in 1/1000th of an inch. So I can very precisely drill a hole, move over exactly an inch, drill another hole, move over 2 inches this way, drill another hole, and back to the 4th hole. So I can make multiple parts, and I can take those and put them on another part that I've made, and everything will fit together. So I can very accurately do things like that. What's in here right now is called an end mill. One of the things you can use it for is cutting slots or machining parts or whatever. That's a piece of aluminum right now.
Let's do it like butter.
This has a digital readout on it. This is reading hundredths of an inch, tenths of an inch, thousandths of an inch, and 10,000ths of an inch. So it's accurate to down to that position. So I can cut slots with it and different things like that. I come up to an inch on the dial. I went past the inch, so I'll go to 1.25 inches. normally, again, you can set stops on this by moving these. So if you're doing a repetitive thing, you can have them all come out the same. And I'm looking for on the dial 2 inches 1 inch 250, which is right there. So if I take that out, I know my cutter diameter is 1.25 inches. And if I actually measure my slot length on this, since I travel 1.25 inches and the diameter is 1/4 there, this should be right at 1.5 inches long. And it's 1 inch 498. So.
Not too shabby. Not too shabby.
Okay,
Wow.
so you can do a lot of different things. If you needed to square up the part, you can hang it out this direction and take a side cut with this, and then the part would be this edge, and then would be perfectly at right angles to each other. So you can end up making parts parallel and whatnot. You could drill up this side to this side, and then you could stand it up this way, take a cut across it, then it would be parallel, and you could machine it to a width if you needed to. It's a real versatile machine. You can use it for drilling holes or shaping metal. Or
Do you need that piece of metal?
no.
Can I take it home, show my kids?
Sure.
Thanks.
Slot on, right? You know, there's a part there that we've come up on the mill. We've located this hole exactly some distance from the bottom up to the center of it.
Do you have days when you focus all on one particular kind of part? Or
Yeah. Typically, what we're doing, the way we build the presses is we don't build them one at a time. We build parts for typically about 50 presses at a
all right,
time.
well, that would be the way to do it.
Yeah,
And then it would be really slow.
And then typically you're running out of some part all the time, so you're always constantly building parts, and it's just a cycle. So.
Is there any predictable cycle to people ordering presses?
No,
I didn't think so.
We haven't figured out yet. Usually the summers are a little bit slower. This summer was not slow though. Usually the summer's a little slower. In time for school sessions start in the fall, usually ball grain plate orders and things like that really increase because people are trying to lay in stock for the next semester and things like that. But
I hope you know that it's raining today because I came down from Washington. I brought it with me.
You brought it with you?
Yeah.
That's all right. I was up there not too long ago, up in Bellingham. So.
Oh, really?
Yeah. And we took the son up there with us for a while. So. And then when we came back down, it rained here too. So. I know how it follows you around.
Actually, here in New Mexico, people dance in the street practically when it rains.
Yeah.
First time I was ever here when it started raining, I was in a restaurant and people cheered.
Oh.
That was 2 years ago.
That's funny.
We were real dry. And
Yeah, we don't do that up in Washington.
no,
This is a machine shop where we do a lot of the parts. The next area over is where the material comes in that we get from the steel mills. Some of the different shapes we use. The drums on your press were started off on a piece of pipe like this. Those are 20 feet
amazing.
long.
That's just a dumb old piece of pipe.
Just looks like a dumb old piece of pipe. It looks like old rusty and everything. The rust is only a few thousandths thick, actually, probably about 10 thousandths thick, and the rest of it's still beautiful.
And you take this stuff, and you make presses out of it.
We make presses. Well, that's all you need to build a press right there.
That's not all I need. I need you guys too.
So there's a variety of, there's different shapes up here. These are called square tubing. There's different diameters or widths and thicknesses of it. You can get it in different walls, and it goes from, this is 1 by 1 up here, 1.5 inches, and this is 2 by 2. This is 4 by 4 down here. So there's just a wide variety of shapes you can get to start with. This is 2-inch solid stock, 5/8 by 2, 3/8 by 2, 3/8 by 5.
I noticed that you're pretty handy with your inches there. You can just tell what things are.
I can tell what most of that is just because I've worked here a long time.